Hello, my brilliant students. A very warm welcome to all of you getting ready for WAEC, NECO, and JAMB. Today, we are diving into a topic that is just so important for your physics exam, semiconductors. This is the tech that powers your phone, your laptop, basically the entire digital world. But more importantly, it's a guaranteed way to score marks if you understand it well. So let's get right into it. Now, we all know about conductors, right? Things like copper wire that let electricity flow very easily. And of course, we know about insulators like rubber that block electricity completely. But what if I told you there's a special class of materials that can do a bit of both? A material that you can actually control, telling it when to conduct electricity and when to block it. Sounds like a real game changer, doesn't it? Well, that amazing material is a semiconductor. The official definition, and you need to remember this, is a material with electrical conductivity that's somewhere between a conductor and an insulator. It's this unique property that makes them the absolute backbone of all modern electronics. This topic is right there in the electronics section of your syllabus for WAEC and NECO, and under Introductory Electronics for JAMB. So, you see, mastering it is a must. To make sure you master this completely, here's our plan for today. We'll start with the basics of what semiconductors are. Then we'll look at the two main types, intrinsic versus extrinsic. After that, we'll see how they are used to build the super important PN junction diode. And then the best part, we are going to solve actual past questions from WAEC, JAMB, and NECO. Finally, we'll wrap it all up with a quick recap and some killer exam tips. Are you ready? Let's do this. Okay, let's jump into our first section. To answer those tricky exam questions, you need to get the basics right. So what really makes a material a semiconductor? Well, it all comes down to something called energy bands. You see, in any solid material, electrons live in these energy levels we call bands. Look at the diagram here. The lower band, which is usually full of electrons, is called the valence band. Now, for electricity to flow, an electron has to get enough energy to jump up to the conduction band, which is mostly empty. That space it has to jump across is called the energy gap, and believe me, the size of this gap is the secret to everything. And this table here breaks it down perfectly. For conductors, the bands actually overlap, so electrons can just slide over and move freely, easy. For insulators, the energy gap is huge, like no way an electron is making that jump, so no current flows. But look at semiconductors in the middle. They have a small, manageable energy gap. So with just a little push, maybe from some heat or light, we can get electrons to jump that gap and start conducting electricity. This ability to be controlled is their superpower. So now we know what a semiconductor is, but you also need to know they come in two main types, intrinsic and extrinsic. And I can tell you for a fact, understanding the difference between these two is the key to answering some of the most common questions you will see on your exams. First up, we have the intrinsic semiconductor. The most important word here is pure. Think of it as pure silicon or pure germanium with nothing else added. In this pure state, if you add some energy, like from heat, a few electrons get enough energy to jump to the conduction band. Now, when an electron leaves its spot, it creates an empty space behind it, and we call that empty space a hole. And since every single electron that jumps creates exactly one hole, the number of free electrons is always equal to the number of holes. Simple as that. The thing is, an intrinsic semiconductor doesn't actually conduct electricity very well by itself. To make it really useful, we have to do something called doping. Now, doping is just a technical word for deliberately adding a tiny, carefully measured amount of an impurity. When we do this, we turn it into an extrinsic semiconductor. And the whole reason for doing this is to massively increase how well it conducts electricity. Okay, so there are two ways we can dope a semiconductor. First, to create an N-type or negative type, we add a pentavalent impurity. That's just an element with 5 electrons in its outer shell, like phosphorus. 4 of its electrons will bond perfectly with the silicon atoms around it, leaving 1 extra electron that's free to move around. That's why in N-type semiconductors, the majority of the charge is carried by electrons. On the other hand, to create a p-type or positive type, we add a trivalent impurity. That's an element with only 3 valence electrons, like boron. It can only form 3 bonds, which leaves an empty spot, or a hole. So in p-type semiconductors, the majority carriers are these holes. Right, now this is where the real magic happens. What if we take a piece of p-type semiconductor and join it to a piece of n-type semiconductor? Well, when we do that, we create one of the most important electronic components ever, the p-n junction diode. This is where all the theory we've been talking about becomes a real practical device that you absolutely need to know for your exams. So the moment you join the p-type and the n-type materials, something really interesting happens. Those extra electrons from the n side immediately see the empty holes on the p side and rush over to fill them up. Right there at the junction, this movement creates a very thin layer right in the middle that has no free electrons and no holes. We call this the depletion region. This region acts like a barrier, and is this barrier that creates that one-way street for electricity. So how do we get the traffic flowing on this one-way street? We connect the battery in a special way called forward bias. It's simple. We connect the positive terminal of the battery to the P side and the negative terminal to the N side. This connection actually pushes the holes and the electrons towards the junction, making that barrier, the depletion region, much thinner. Once the voltage is strong enough, current can flow easily. Just like that. The diode is switched on. But what happens if we connect the battery the other way around? Well, that's called reverse bias. Here, the positive terminal is connected to the N side and the negative to the P side. This time, it pulls the electrons and holes away from the junction, which makes the depletion region wider and the barrier much stronger. So basically, no current can flow. The diode is effectively switched off. This on-off one-way action is the secret to everything a diode can do. So what do we use this amazing one-way electrical switch for? Its most important job is rectification. And rectification is just the process of converting the alternating current, or AC, that we get from our wall sockets into the direct current, or DC, that all our gadgets like phones and laptops need to work. This is a massive application, and it's a favorite topic for WAEC practicals and theory questions. You absolutely must know this. Alright, you have worked hard to learn the theory. Now it is time for the most important part, applying what you've learned to real exam questions. We are going to solve one past question each from WAEC, JAMB, and NECO. Please pay close attention to how we break down the question and structure the answer. This is how you score maximum marks. Let's begin with WAEC Physics from 2023. The question asks for two things. First, state one difference between an intrinsic and an extrinsic semiconductor. And second, draw a circuit diagram for full wave rectification with smoothing. This is a classic question that tests both your knowledge of the theory and your ability to apply it. Here's exactly how you get full marks. For the first part, give a clear and simple definition. Intrinsic semiconductors are pure, and the number of electrons equals the number of holes. Extrinsic semiconductors are doped with impurities, so the number of charge carriers are unequal. For the second part, the diagram is everything. You must draw the AC source, a transformer, the 4 diodes arranged in a bridge, the load resistor, and, this is the secret for smoothing, a capacitor connected in parallel with the resistor. Label every single component clearly. Now, a very common mistake students make here is mixing up the definitions. They forget which one is pure and which one is doped. Just remember this easy trick. Extrinsic sounds like it has the word extra inside it. You add extra impurities to make it an extrinsic semiconductor. Don't lose easy marks on this. Okay, let's look at a question from JAMB 2023. Notice how direct and straight to the point it is. True or false? The number of holes in an intrinsic semiconductor is equal to the number of free electrons. I'm telling you, JAMB loves to test your basic understanding with questions just like this. There's nowhere to hide. You either know it or you don't. And the answer, of course, is true. We just talked about this. In a pure intrinsic material, for every electron that breaks free, a hole is created. They are created in pairs. So the number of electrons, which we call N, must be equal to the number of holes, which we call P. It's a fundamental rule. Now, listen carefully. Here is the trap that JAMB often sets for students. The rule that N equals P is only true for intrinsic pure semiconductors. The very moment you dope the material and make it extrinsic, that rule is broken. For N-type, you have way more electrons than holes. For P-type, you have way more holes than electrons. You must know this difference. Finally, let's look at a typical multiple-choice question from NECO. A semiconductor diode is used for rectification mainly because your options are A, is nonlinear, or B, allows current in one direction only. Think about it for a second. What is the main reason, the fundamental reason we use it to change AC to DC? The correct answer is B. This is a perfect example of choosing the best answer. You see, while it is true that a diode is a nonlinear device, that's not the main reason it's used for rectification. The fundamental reason, the core property, is that it allows current to flow easily in one direction, forward bias, and blocks it in the other direction, reverse bias. It is this one-way action that makes rectification possible. Excellent work getting through those questions. Let's move to our final section for a quick summary and some last-minute tips to help you score high. This is the part of our session you want to pause and take a screenshot of for your revision notes. All right, let's run through the key points one last time. Intrinsic, pure, where number of electrons equals number of holes. Extrinsic, doped, where they are not equal. N-type, majority carriers are electrons. P-type, majority carriers are holes. Forward bias lets current flow. Reverse bias blocks the current. And the main application we discussed is rectification, changing AC to DC. Got it? Good. And here are my final tips for you. Number 1, if they ask you to draw a diagram, draw it big, draw it neatly, and label everything. Examiners award easy marks for this. Number 2, do not mix up your dopants. N-type impurities are called donor atoms, while P-type are called acceptor atoms. Number 3, know your exam. JAMB loves theory questions. WAEC and NECO love to test applications, like rectification. And my final, most important tip, practice, practice, practice with past questions. It is the best way to prepare. I want to tell you that you can absolutely master this topic. Semiconductors might seem a little complex at first, but once you understand these core ideas, it becomes a very high-scoring area in your exams. You have everything you need to succeed. So please go into that exam hall with confidence. We can smash these exams together. If you found this lesson helpful, please do me a favor. Like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also, remember to visit ExamKP.com for thousands of free practice questions and answers. Let's smash these exams together.